Alright, what's up guys? It's Garrett here with Ride Rivian. Okay, the internet is going crazy about this Ford F-150 Tesla Cybertruck tug-of-war. Everybody's saying that it was unfair, and now today one of the Ford executives has challenged Elon Musk to another tug-of-war, quote, an apples-to-apples tug-of-war. They're claiming it's not fair. So what I did, I'm a mechanical engineer, and I wanted to actually analyze this tug-of-war and see what, if it really was fair, all right? And it actually comes down to one simple thing that I'm going to explain here in a bit. So I'm going to go over a very brief and very simplified analysis of the physics behind this tug-of-war to hopefully give you guys a better idea of what Tesla actually did to help them in their favor. And it's not like they were trying to tweak it, but there's just some things about the nature of electric vehicles versus standard truck that actually play in their favor. So let's jump into it and go into the analysis. Alright, so here we have my beautiful drawing of the Ford F-150. You can obviously tell that's what it is. And the Tesla Cybertruck, which a week ago you would have said, well, that's a crappy drawing of a car. But we can all recognize it now as the Cybertruck. But, okay, so I have some specs here, and they're obviously some assumptions, right? So the Ford F-150, I'm assuming, is 4,000 pounds, while the Cybertruck is 5,000 pounds. And the exact weight doesn't really matter. It's more the difference between the two, which 1,000 pounds is a very conservative estimate. I would guess anywhere from 1,500 to 2,000 pounds based off of the material choices of Tesla. All that cold-rolled steel is going to be extremely heavy. Also the batteries. If you have 250 kilowatt hours of batteries, that is going to be extremely heavy. So, okay, let's jump into some other crucial information. So, the center of mass of the truck, of a standard truck, is shifted forward because most of the weight is in the front, while the bed is relatively empty. So I'm going to assume that the center of mass of this truck is 60 inches behind the front wheel axle. And you can tell in the video that this is a Ford F-150 Super Cab, and that particular version of the truck has a 145-inch wheelbase. For the Tesla, I don't have that information, and that is because I'm making the assumption that the center of mass is pretty much in the middle. Most of the weight in a Tesla, or in an electric vehicle for that matter, is in the base of the car right here, and it's spread out pretty evenly. So with that, I can assume that the weight is pretty much in the middle, and that you have almost the same weight on each wheel. Okay, so for the Ford F-150, what we have to do is sum the moments, or the torques, in order to find how much weight is on this back wheel versus how much weight is on this front wheel. This front wheel has a lot more weight on it, but this is the wheel that's actually driving the car forward, okay? And Tesla used this to their advantage. Whether they did that on purpose or not, I don't know, but this is how it all worked out. So by doing that, we can figure out that the weight on this back wheel set is about 1,655 pounds, okay? So that is significantly less than this 4,000 pounds. And then if we take into account the friction, which will be the same for both cars, with a coefficient of 0.7, the frictional force for the F-150 is 1,158 pounds, all right? For the Tesla Cybertruck, it's going to be the same for each wheel. So we just do the total weight times 0.7 again, and we get 3,500 pounds for the frictional force. Okay, so this is your effective frictional force, right? So this is the friction that is actually going into moving the truck forward, okay? And you might be saying, okay, well, these trucks can tow way more than this amount, right? So how is that possible? The Cybertruck can tow anywhere from 7,000 to 14,000 pounds, right? So what is this measly 3,500 pounds, okay? When they give you those numbers, that is assuming that whatever they're towing is on wheels, okay, that it can roll. If it couldn't roll, there's no possible way that the car could pull more than this pound, because it would just slip like that. This is your frictional force. It can't pull more than it has grip on the ground, right? And again, this is not the exact numbers. This is with our assumptions, but we can, I don't know, they're relatively close. Okay, the point is the comparison here. So these are obviously not close to each other, and hence the Cybertruck completely dominated the F-150 in this particular test. Okay, I wanted to go into one other thing about the hill. So Tesla made this big deal about how they are pulling the F-150 up the hill, so it makes it even harder, right? Which is true, but at the same time, because it's on a hill, there's technically less weight on this back wheel, even less than there already was. However, the ratio between your weight that you're losing on this back wheel and the weight or the force that you're gaining by gravity wanting to pull the car downhill is very small. So the gravity has a much larger effect on it. So yes, Tesla is right in that it is harder for the Cybertruck to pull the F-150 uphill. Okay, so what I have here, this F minus is the weight that's going against the Cybertruck, okay, due to gravity. This F plus is the weight or the force that the F-150 has going, helping it because of gravity, because we've tilted it in that manner, in that direction. This XN or X new is this frictional force, the adjusted frictional force, because there is less weight on this back wheel. Okay, so what I did is set these equal to each other because I wanted to see the equilibrium. At what angle would these two trucks be on a level playing field, okay, an apples to apples tug of war? And it's a huge 15.4 degrees, which is a 27% grade, which is massive. So that's what they would need to do. They need to put it on a very steep hill for these two particular trucks to be an apples to apples tug of war. So I'm assuming that's not what they're going to do on this rematch that we're hoping to see soon. They will probably put it up against a car of equal weight, and then see what they can do. I'm super excited to see that. We'll keep you guys posted. But yeah, that's the analysis of the Tesla Ford F-150 tug of war. So thanks for watching, guys. Hit the subscribe button if you want to get more information on Rivians or electric vehicles in general. We'll be posting videos every week. So yeah, stay tuned. Thanks.